Hello everyone, welcome to the first lecture of differential equations. So I am going to talk about basic terminologies in this lecture. If possible, I am going to talk about how to find the solution of one type differential equation. So let's get started. So what is the definition of a differential equation? An equation which contains derivatives of different orders, okay, with respect to one or more independent variables is called differential equation. Okay, so now what is this independent variable and dependent variable? You know all these things, but I'm just telling you as a recap. So let's say y is a function of x. So when x is changing, depending upon x, y is changing. So here x is the independent variable while y is the dependent variable. Okay, so again, this there is two types of differentiation. One is ordinary differentiation, and another one is partial differentiation. Okay, this is written as dy by dx, and this is written as dou phi by dou x, or dou phi by dou y, or dou phi by dou z. Now let's take phi as a function of xyz, xx square yz. So while doing this partial differentiation of phi with respect to x, we will consider y and z terms as constant. Now let's see this example. So here we will differentiate x and it becomes 2x, while y, z remains constant. Similarly, you can do for y and z. Okay, now this is ordinary differentiation, and we are differentiating y with respect to only one independent variable x. Okay, so depending upon these derivatives, we have two types of differential equations. One is ordinary differential equation and another one is partial differential equation. So in ordinary differential equation, this equation contains ordinary derivatives, and it is with respect to only one independent variable. Here, one independent variable. But in partial differential equation, it contains partial derivatives with respect to two or more independent variables. So let's see an example of ordinary differential equation. We can simply write d square y by dxx square plus 6 dy by dx plus y is equal to x. This is the ordinary differential equation because it contains only ordinary derivatives. Okay, an example of partial differential equation you have already encountered in electromagnetic theory, that is Laplace equations, which is dou square phi by dou x square plus dou square phi by dou z square plus dou square phi by dou y square. Okay, you understand that this y comes here. Okay, this is Laplace equation. You must have you must have heard about it. Okay, this is all about the definitions of differential equation and types of this differential equation. Now let me go to the next slide. Now we will see two important terms in a differential equation. One is order of the differential equation and another one is degree of differential equation. What is the order of differential equation? The order is we first choose the highest order derivative term in this given differential equation. Then the order of that highest derivative gives us the order of differential equation. Like let's see this example. Here is d square y by dx square plus 9 dy by dx plus y is equal to e power x. Okay, like I said, we have to find the highest order derivative term. Here is the highest order derivative term, d square y by dx square, and this order 2 gives us the order of differential equation order. Okay, now our second job is to see the power of that highest order derivative. Like here, this power of this highest order derivative is 1. So for this equation, degree is 1. Let's take another example. Let's say we have d square y by dx square 2 plus dy by dx power 3 plus y is equal to x. Okay, don't say the degree is 3. No. Our first job is to find the highest order derivative, which is here d square y by dx square. Okay, then power of this highest order derivative gives us the degree. Okay, so here 2 is also the degree. Okay, so now let me take a complicated example. Let's say we have a differential equation like d square y by dx square power 2 by 3 plus 6 dy by dx power 3 by 2 plus y is equal to sin x or something function of x, or 0, you can take 0, and anything, RHS doesn't matter here. Okay, so what should we do now? We can write down simply that the order is 2 here, highest order derivative is 2, so we can write down order is 2 and power is 2 by 3, so degree will be 2 by 3. But remember, degree is never a fractional quantity, it has to be an integer. Okay, so our first job is to make this differential equation free from these fractional powers. So for that, what we have to do, we can simply multiply 3 here, then 3 will get cancelled out, so 2 will be the degree. No, we have to make the differential equation free from for fractional powers. So we will take the LCM of these denominator of fractional numbers, then multiply both the terms. So here the LCM of 3 and 2 is 6, so here multiply 6 and here also multiply 6, so this becomes 9 and this becomes 4. And now don't say 9 is the degree because it is highest. No, we have to choose the highest order derivative to find order, and power of that highest order derivative gives us a degree. Okay, so here this becomes 4. Okay, so this term becomes d square y by dx square power 4. Here order is written as 2 and the degree will be 4. Okay, so let me conclude this slide. So whenever we are given a differential equation and we are asked to find the order and the degree of the differential equation, so our first job is to find the highest order derivative term in that equation. Okay, and that order of that highest derivative term will give us the order of the differential equation, and that power of the highest order derivative term will give us the degree of differential equation. I think this is clear. And another point, that whenever there is a fractional power in the differential equation, we have to make that differential equation free from fractional powers, not that specific term. We have to make the differential equation. If there is two powers that are fractional, then we have to take LCM of the denominator of both the powers, then multiply with them. Okay, and finally that will give us the degree of the differential equation. Okay, so I think this slide is clear now. Let me go to the next slide. So what is the linear ordinary differential equation? So for an ordinary differential equation to be a linear ordinary differential equation, it has to satisfy 2 points. One is power of dependent variable and its derivative are equal to 1. It has to be equal to 1. So what is saying? So this differential equation must contain y dy by dx, d square y by dx square, and dqy by dx q, and so on. Okay, but the power of this derivative terms and this independent variable term must be 1. So here this power is 1, here this power is 1, here this power is 1, and here this power is 1. So the power of these terms must be 1. Okay, now the second point is, there must not have a term which contains product of dependent variable and its derivatives, or two derivatives of different orders, or both. It means if an ordinary differential equation contains terms like y into dy by dx, it is not a linear ordinary differential equation. If it contains y into d square y by dx square, then also it is not linear ordinary differential equation. And also if it contains dy by dx into d square y by dx square, then also it is not a linear one. Okay, you have to remember that. So basically for a ordinary differential equation to be linear, that must satisfy these two conditions. One is power of dependent variable and its derivatives must be 1, and there shouldn't be any term which contains the product of the dependent variable and its derivatives, or the product of two derivatives which have different orders. Then only we can say that ordinary differential equation is a linear one. Okay, so I think this part is clear. Let me go to the next slide. Yeah, now comes the important part of this lecture. So what is the solution of ordinary differential equation? Generally what happens in the exams, you are given a differential equation and you are asked to find its solutions. Okay, so what do you mean by this solution of ordinary differential equation? So finding the solution means we have to find the relationship between dependent and independent variable. Basically we will find y as a function of x. This is independent variable, this is dependent variable. Okay, so we will find if there is a differential equation, then we will find the solution as this one. This is the solution we get. Okay, so what is this? This is the relationship between y and x. Okay, so basically solution gives us the relationship between dependent and independent variables. Okay, now this is also two types. One is general solution and another one is a particular solution. So what is this general solution? So whenever we are given a differential equation, then we simply find its solution. We will get solutions, for example, like c1 e raised to 2x plus c2 e raised to 3x, like this we will get. Here we don't know the value of c1 and c2, it can be anything. Okay, so these are called arbitrary constants. Like while integrating, we get an integration constant, and then after that we find that value. So in this case also we will find arbitrary constant, and the number of these arbitrary constants will be equal to the order of the differential equation we have been given. Okay, so now if we don't know this value of c1 and c2, then this is called the general solution of that differential equation. Okay, now let's say we have given a condition like y at x is equal to 0 is 1, and dy by dx at x is equal to 0 is 2. If we apply these conditions in this equation, we can find c1 something or c2 something. Then we can write down, let's say c1 is 2 and c2 is 5. Then this equation becomes 2 e raised to 2x plus 5 e raised to 3x. Then this becomes particular solution. Okay, so basically solution of ordinary differential equation gives us the relationship between dependent and independent variable. Okay, and then the general solution gives us there are some arbitrary constant, value of which we don't know. Okay, unless we are given some initial conditions, we cannot find this arbitrary constant. So in general, the arbitrary constant is not known. Okay, so we call this solution a general solution, and if we are given some conditions, then we can apply these conditions to the general solution and find the particular values of arbitrary constants, here c1 and c2. Okay, then we can tell that solution is particular solution. Okay, now let's go to the next slide. Now this is the question I have been asked in, I think, either Mohali or some interview, in PhD interview. You can be asked in some other interviews also. So what is the physical significance or geometrical meaning of this solution of ordinary differential equation? So let me just write it, just read it out, and after that I will explain it elaborately. Don't worry about that. So general solution represents a n parameter family of curves, where this n parameter, the number of parameters, is equal to the number of arbitrary constants we get, and this in turn is equal to the order of the ordinary differential equation we have been given. Okay, then this particular solution represents a particular curve of this n parameter family of solutions. So in the previous slide, what you saw is, in general solution we don't know the value of arbitrary constant, so this is called general solution. In general, we don't know the value of c1 and c2. So out of that values of c1, c2, if we take only one pair of values like c1 and c2 or 2 and 5 we took in the previous slide, so this becomes particular solution. So it is saying that the general solution gives us the n parameter family of curves, and if we are applying these conditions, we can get a particular curve out of that n parameter family of curves. Okay, let's take an example. Now let's say this is example. Let's say I got a solution like in the form x square plus y square is equal to c1. Okay, so generally what you tell, that this is a equation of circle which has origin at 0 0, and it has radius is equal to under root c1. You tell that, but this is not right, because this cannot be a circle, because you don't know the value of the radius. Till you don't know the value of the radius, you cannot tell this is an equation of circle. This is wrong. Then what is the right term? The right term is, this is a one parameter family of circles. Family of circles. Why one parameter? You just talked about n parameter. In that time, at that time I told that this n is equal to the number of parameters, which is equal to the order of the ordinary differential equation, which in turn equal to the number of arbitrary constant. Here, what is the number of arbitrary constant? Here is one arbitrary constant. This one, c1. This is arbitrary constant. Okay, so there is one arbitrary constant. That's why it is called one parameter family of circles. So why this family of circles? Since we don't know the value of c1 can be anything. So for different values of c1, it gives different circles. Simply, if we are interested to put it in this curve, then we will get, here is one circle, this is for one value of c1. Here is another circle, this is another value of c1, and this is another circle, this is for another value of c1. So this process goes on because we don't know the value of c1. If we know the value of c1, then it will represent only one circle. Okay, let's see, here we have this c1 as 4. So what the equation becomes is x square plus y square is equal to 4. Here radius is equal to 2. So if we put this equation here, it becomes like this, only single, this is 2 units, the radius is 2 units. It may be centimeter or meter or millimeter, anything, any unit. Okay, so if we see this equation, then this is a particular circle. So this we can tell this is an equation of circle with radius 2 and origin at 0 0. But when we are talking about this equation, we don't know the value of c1. c1 can be anything. So depending upon that value of c1, we can draw many circles. That's why it is called the family of circles. This is called family of circles. In this way, we can have family of straight lines, we can have family of parabolas, we can have family of hyperbolas. Okay, that's why in general it is called family of curves. And n parameter so the number of arbitrary constants we get in that that will give us what parameter we are taking. Like in this case there is one arbitrary constant, so it is called one parameter. And if you take some other curves, then the arbitrary constant will be different. Okay, so this n parameter we are writing in general. Okay, so I think this part is clear. So now let me go to the next slide. Yeah, so let me take another example so that your fundamental will be clear. Okay, if you cannot understand the last slide, let me take another example. Let me take an equation like mx plus c. You all will say that this is an equation of straight line, and you know what I'm going to say. This is wrong, obviously wrong, because here we have two arbitrary constants m, c. These are arbitrary constants. Arbitrary constant. Unless we are given some conditions, we cannot find the value of m and c. Okay, until that we will say this is two parameter family of straight lines. Why two parameter? It is clear that there are two arbitrary constants, that's why two parameters. And why family of straight lines? Depending upon these values of m and c, we will have a number of straight lines. Like here is one straight line, here is one straight line, here is one straight line, one is here, one is here. Anything, it can be anything, because in all the cases m and c are different. Okay, so unless you know the values of m and c, this equation will give two parameter family of straight lines. If m is equal to 2, c is equal to 1, then we can write y is equal to 2x plus 1. And if we plot this curve, then it becomes like slope is 2 and the intercept is 1. It can be like this. Okay, then this becomes equation of straight line. Equation of straight line. Okay, because we got the values of 2 and 1 as m and c. That's why we can now tell that this is an equation of straight line. Okay, so if we don't know the values of arbitrary constant, in general we will say we got a family of curves, n parameter family of curves. Okay, I think this part is clear. Now let's go to the type 1 first order differential equations. And first one is the separation ordinary differential equation. So what is this separable ordinary differential equation is? In this case we will be able to separate the variables. It means if, we can take all the independent variables to one side of the equation and all the dependent variables to the other side of the equation. Okay, so let's see. So the form of this kind of differential equation is, the form can be written as dy by dx is equal to function of xy which can be separated as phi x by gy or phi x into gy. So we can just take x term to that side and y dy to this side, so it can be separated. So let's take this format. So dy by dx is equal to phi x by gy. So we can take now gy to that side and dx to this side. This equation becomes gy into dy is equal to phi x dx. So now we can simply integrate both sides and we will get a arbitrary constant here. So can you tell me which type of solution this is? It is particular solution or a general solution? This is a general solution, since we don't know the value of c. Okay, if we there is a condition like y of 0 is equal to 1 or something like that, we can find the value of c, then we can put it here, we will get particular solutions. Okay, so let me take an example. After that I will give a home task for you. So let me take the example. The question is y by x dy by dx is equal to under root 1 plus x square plus y square plus x square y square. Okay, so what can we do here? So this can be written as y by x into dy divided by dx is equal to 1 plus x square plus y square 1 plus x square under root. So this again can be written as y by x dy by dx is equal to 1 plus x square into 1 plus y square, and we can take this 1 plus y square to this side and bring x dx to this side. This will become y dy divided by under root 1 plus y square is equal to x under root 1 plus x square dx. And we can now integrate both sides as the variables are separated now, and there is an arbitrary constant. Okay, so you can now try this one. Okay, so let me do this one and I will give you a homework. Okay, now we can substitute 1 plus y square, and the equation was y dy divided by under root 1 plus y square integral is equal to x under root 1 plus x square dx with an arbitrary constant. So now we can put 1 plus y square as z square, so it will become y dy is equal to z dz, and 1 plus x square, let's put p square, then x dx becomes p dp. Okay, so substituting all these things here, we will get z dz divided by z is equal to we get p dp, x dx is p dp, and under root 1 plus x square is p, so it will be p square dp plus c. Okay, so we can do simple integrations. So it becomes z cancels out, so this becomes z is equal to integration of p square becomes p q by 3 plus c. So we know the value of z and p. Let's put these values now. So it becomes 1 plus y square is equal to 1 plus x square whole power 3 by 2 divided by 3 plus. Okay, so this is the solution. I think you get it. So basically you should have some knowledge about the differentiation or integration. Okay, then only you can solve these questions and you can do it easily. It's not that complicated. Okay, so now homework for you. So the homework is, let's say a particle is there, particle mass is m and it is moving along x direction, along positive x direction and it experiences a resistive force, experiences a resistive force which is minus gamma v square. Okay, so now here gamma is constant. Let me write down, otherwise you can assume anything. Okay, so gamma is constant. Okay, now you have to find the find velocity at time t if there is a condition, if velocity at time is equal to 0 is v naught. Okay, so to help you I am giving you some options here. So one is v naught e raised to minus gamma v naught t by m. Second one is v naught 1 plus log 1 plus gamma v naught t by m. Third option is m v naught m by gamma v naught t, and last one is 2 v naught 1 plus e raised to gamma v naught t by m. Okay, so try this one, and if you can do it, it's a good thing, and if you can't do it, so tell me in the comment section, or you can also text me through Gmail or WhatsApp. I will attach both of them. Okay, so that's it for today. We'll see in the next lecture, so don't be stressed. Okay, so I have explained many things. If you don't understand something, you can ask me. I will explain you 1,000 times. Don't worry about that. Okay, so okay, so stay safe, stay home, stay safe, and bye bye. See you in the next lecture.